So in this video, we're going to go over factoring polynomial expressions. So we've had some experience, but we stuck to just factoring quadratic expressions. But now we can have any type of polynomial expression that can be factored. So what we're going to go through are all of the patterns to look for in factoring. So we've got a few already. Okay, so what we've got is greatest common factor. We've got our quadratic trinomial, which was, if it looked like a quadratic trinomial, we were using the AC method, right? That was our method. That was if we had ax squared plus bx plus c, and then we had the difference of two squares, which the difference of two squares was anytime you can take a quantity and write it as a quantity squared minus a quantity squared, it would factor to be a plus b times a minus b. So if you could take a two-term expression with a difference, okay, between the two terms, and write them as a quantity squared minus a quantity squared, it is the difference of two squares, and it will factor to be a plus b times a minus b. But now we've got to add a few more factoring patterns. So the factoring patterns, okay, that we also have to look at, now that we're growing past just having degree of 2, right, that word degree is part of polynomials talking about the exponent. So we also have to worry about, I'm adding a few more, okay, the difference and sum of two cubes. So that's new. We're going to talk about that. Okay, so not only do you have a difference of two squares, you actually have a difference of two cubes and a sum of two cubes. We have factor by grouping, which you actually do inside of the AC method. You do factor by grouping. And then something called quadratic form. Okay, so when you have to factor an expression, it's going to be super important in terms of graphing polynomials as well as solving polynomials, being able to factor a polynomial. You have to pick out patterns. So remember, we start by looking for greatest common factor, okay? And then we look and we look at the expression we have, okay? So if we have three terms, we should be looking, is this a quadratic expression, okay? If we have two terms, now what we're going to be looking at is this a difference of two squares? Is this the sum of two cubes? Is this the difference of two cubes? And then I'm going to talk about what we should be looking for when we should be approaching it using factor by grouping and quadratic form. So we're going to get started by looking at the difference and sum of two cubes factoring pattern. So if you have the sum of two cubes, that means you can write your two-term expression as a to the third plus b to the third. And if you can write it as a to the third plus b to the third, it will factor to be a plus b times a squared minus ab plus b squared. Okay? If you don't believe me, distribute this out and you'll be left with a to the third plus b to the third. Now, sum and difference of two cubes. Don't forget your perfect cubes. Okay? I'll just make a quick list from 1 to 10. Okay, 1, 2 to the third is 8, 3 to the third is 27, 4 to the third is 64, 5 to the third is 125, 6 to the third is 216, 7 to the third is 343, 8 to the third is 512, 9 to the third is 729, and 10 to the third is 1000. Okay, so the factoring pattern, so I'm just going to give an example, okay, of sum of two cubes. 8x to the third plus 27 fits the factoring pattern of sum of two cubes. You have a two-term expression, and you can take both of these terms and write them as perfect cubes. What to the third is 8x to the third? 2x. What to the third is 27? 3. So a is 2x and b is 3. So this factors to be a plus b, which would be 2x plus 3, times a squared. So take 2x and square it. That's going to give you 4x squared. This is one of the most common mistakes. 4x squared. A is 2x. Okay? 2x times 2x is 4x squared. Minus, it's always a minus here. always a minus when it's sum of two cubes. That's a positive, that's a minus, that's a positive. Same as that, opposite as that. Always positive there. Okay? So minus a times b is going to give you 6x, and then plus 3 squared is 9. Now, as long as you took out the greatest common factor here, okay, this is what's called a prime polynomial, meaning you're not going to be able to factor this again. This is very close to being the perfect square trinomial. It would be a perfect square trinomial if that was minus 2ab, but it's not minus 2ab, it's just minus ab, so that's why if you try and factor this, you're not going to be able to. But notice, we were able to take a degree 3 polynomial, and we were able to write it as a product of a linear times a quadratic, okay? So now let's get into the difference of two cubes. Once again, this is a two-term factoring pattern. So if you can write your two-term expression as a quantity to the third minus a quantity to the third, it will always factor to be a minus b times a squared plus ab plus b squared. So, an example of this would be, we can do, let's do 64x to the third minus 1, okay? So, I have two terms, which means what you should be looking at from now on when you have two terms is, and you have to factor, is this a difference of two squares? Is this the sum of two cubes? Is this a difference of two cubes? This is a difference of two cubes. I can write this as a quantity to the third minus a quantity to the third. 64x to the third is 4x to the third power. 1 is the same as 1 to the third. So this factors to be a minus b, so 4x, a is 4x, b is 1, so this is going to be 4x minus 1 times a squared. 4x squared is 16x squared, plus, this is always a plus sign here. Notice, when it's minus here, this is negative, this is positive, this is always positive. Okay, plus a times b, that's going to be 4x, plus b squared, b is 1, 1 squared is 1. Okay, you can try and factor this. This won't be factorable, okay? It's going to be prime as long as you took out the greatest common factor there. Okay, so here's what sum of two cubes is again. Here's what difference of two cubes is. Know these factoring patterns. You need to remember what these factor to be. This, okay, this expression right here factors to be this expression. You can write it as a product. A to the third minus b to the third factors to be this product right here. You need to know that. Okay, so we covered sum of cubes, difference of two cubes. What we can move on to now is factor by grouping. When you have an even number of terms, you're going to want to try and factor by grouping. Usually, we'll see 4 terms when this happens, okay? I'm going to change to a different color. Okay, so factor by grouping. Okay, you usually do this when you have 4 terms, 6 terms, an even number of terms. This is probably the method you would want to use. And here's an example of one that you can factor by grouping, okay? If you have, let's see, 2x to the third plus 2x squared minus 3x minus 3. So when you do this, okay, you are going to want to, and that looks like that marker is going too. So you want to make sure that you're in standard form, and you are, okay? So factor by grouping, you're going to do that when you have an even number of terms. So first off, check to see if there's a greatest common factor you could take out. There's not. Okay? So the factor by grouping is actually used within the AC method. So what we do is we group together, if there's 4 terms, we're going to group together the first 2. That's going to give us 2x to the third plus 2x squared. Okay? We're going to always, remember, always put a plus sign between. Okay? Then this is going to give us negative 3x minus 3. Okay? Okay? So now we take out the greatest common factor of each set of parentheses. We never change the value. This is the same expression as above, okay? They're the same value. Take out the greatest common factor of each. So this is 2x squared. And this would leave you with x plus 1. Greatest common factor here, I could pull out a -3. That would leave me with x plus 1. Okay? From AC method, you should know, here's a quantity, here's a quantity. What is the greatest common factor between those two quantities? X plus 1. And what would be left if you factored out x plus 1? 2x squared minus 3. So you were just able to take this 4-term expression, okay, and write it as a product of its factors. X plus 1, 2x squared minus 3. Notice, this is a degree 3. You were able to write it as a first degree times a second degree. Okay, so this is factor by grouping. We can practice another one of those. Why don't we try 7x to the third minus 7x squared plus 5x minus 5. Okay, so notice 4 terms. You would go to factor by grouping, okay, if you have to try and factor this. Notice this is degree 3, okay? So this is 7x to the third minus 7x squared plus 5x minus 5. Take the greatest common factor out of each set of parentheses. Greatest common factor here is 7x squared. That's going to leave you with 7x minus 1. Greatest common factor here, whoops, not 7x minus 1, x minus 1. Greatest common factor here is 5. I'm going to take out 5. It's left with x minus 1. Remember, these should be the same here, otherwise you can't factor. And remember, if one was x minus 1, and the other one you got to be negative x plus 1. If you factor out a negative here, you're going to be left with x minus 1. So sometimes you might have to factor out the negative. So what does this quantity and this quantity, what's the greatest common factor? You factor out x minus 1, and what would you be left with if you took x minus 1 out from each of those two terms? Times 7x squared plus 5. Notice, we're able to write it as a product. We talked about why you would want to be able to take an expression right as a product. If it's set equal to 0, you then can use a zero product property, which allows you to solve equations. Okay, so that's factor by grouping. We want to do that when we have an even number of terms, okay, greater than 2, so 4 terms, 6 terms. And now we're going to go into quadratic form. So, quadratic form is if you can take any trinomial and write it like this, where whatever goes in here is the same, okay? So if you can take if you could take any trinomial, okay, and you can write it so that it mimics a quadratic. So in this case, I'm going to use the letter U, okay? If you can take an expression and write it so that it mimics a quadratic, you can factor it using the AC method, okay? So for example, x to the fourth plus 2x squared minus 24. This mimics a quadratic because I can write this like so. And these two would be the same thing. This would be x squared. So as long as these two are exactly the same, then this is very similar to being a quadratic trinomial. It mimics a quadratic trinomial. It actually is, except your variable is x squared and not just x. So you would now do the AC method here, okay? So what two numbers multiply together to give you a times c would be 1 times negative 24, which would be negative 24, and b here is positive 2. What two numbers multiply together to give you negative 24 and add together to give you 2? That's going to be negative 4 and 6. So now, okay, when we break this up, it's going to be x to the fourth plus, I'll just do minus, actually, minus 4x squared plus 6x squared minus 24. So check to make sure, can you write it to look like, to mimic a quadratic? Yes. Now, what we want is, right, in the AC method, we were always breaking that up. So we're breaking it up again. We're going to replace plus 2x squared with minus 4x squared and plus 6x squared. And now look, all we're going to do, what we just made was 4 terms. Now, inside the AC method is actually factor by grouping. This is x to the 4th minus 4x squared plus 6x squared minus 24. This is going to be x squared times x squared minus 4 plus 6 times x squared minus 4. What does this and this have in common? What factor? They share a factor of x squared minus 4. If we factor it out, we'd be left with x squared plus 6. Let's not worry about factoring any further for now. And that's what we would be left with. Okay. So, this is quadratic form. We could practice another one. X to the 10th minus 4x to the 5th plus 3. Okay, so it doesn't jump out at you. This isn't a quadratic, but perhaps it's quadratic form. The first thing is it's got to be a trinomial, so it is. So now, can I take this and write this as something squared minus 4 times something plus 3, and these somethings are the same thing? Because if they are, then it mimics x squared plus bx, right, plus c, where these are the same thing. So, what squared would be the same as x to the 10th? That's going to be x to the 5th. Well, x to the 5th. So if you notice, this always has to be double whatever this is, because you're basically squaring it, right? Property of exponent should be multiplying there. So as long as whatever this is, this number is double that, then you know you're on track to, you should be checking to see if this is factorable, okay? So yes, this fits. So we can use the AC method on this. So a times c, 1 times 3, so a times c is positive 3, and b is negative 4. So what two numbers multiply together give you positive 3, and add together give you negative 4? That's negative 3 and negative 1. So this is going to be x to the 10th minus 3x to the 5th minus 1x to the 5th plus 3. Factor by grouping. Always put a plus sign between, right? Okay. Take out the greatest common factor of each set. That's going to be x to the 5th here. It's going to leave me with x to the 5th minus 3. Greatest common factor here would be negative 1. Why are we going to take out a negative 1? Because remember, these factors need to be the exact same thing. Because now between these two quantities, we're going to factor out the greatest common factor, which is x to the 5th minus 3. And we'd be left with x to the 5th minus 1. So we were able to take this standard form of this polynomial and write it as a product of its factors, okay? So we'll do a few more where we have to factor completely. So that means you keep factoring until you can't factor anymore. You can't factor anymore as long as all of your factors are prime. So prime means there is no other factor than itself and 1, just like we know about prime numbers. So you keep factoring until all of your factors are prime. So let's go and let's factor completely. Okay. So number 1, let's do x to the 5th minus x. So the first thing we should be looking for is there a greatest common factor? Yes. The greatest common factor is x. So we should be factoring that out. If we factor out an x, we get x to the 4th minus 1. So now we check and we see, okay, x to the 4th minus 1, that's 2 terms. So we need to check to see if it's factorable. We only have 3 patterns for 2-term expressions. We have the difference of 2 squares, we have the difference of 2 cubes, and we have the sum of 2 cubes. This definitely can't be the sum of 2 cubes, okay, because that's a minus there. So let's check. Can we write this as the difference of 2 squares? X to the 4th is the same as x squared to the 2nd minus 1 is 1 squared. So were we able to write this as a difference of 2 squares? Yes, that means that this factors to be x squared minus 1 times x squared plus 1. So this becomes now x times x squared minus 1 times x squared plus 1. So we just factored down x to the 4th minus 1, but that does not mean we just stop. We now need to look. The factors I just produced, x squared minus 1, that's 2 terms. I need to check again whether or not this is factorable. It's 2 terms. This could be the difference of 2 squares. Does it satisfy that condition again of being something squared minus something squared? Yes, this time's x to the 2nd minus 1 to the 2nd. So x squared minus 1, this factors to be x plus 1 times x minus 1. Okay, we still got this x outside, right? That GCF of x. You cannot, when you're factoring an expression, you cannot lose any of the factors. And now, x squared plus 1. So for a second, I want you to think about that. Think about the patterns we have with 2 terms. We've got sum of cubes, difference of cubes, and difference of squares. Does this fit any of the 3? No, it does not. There is no sum of squares with real numbers. So this cannot be factored. This is prime. So x plus 1 is prime, x minus 1 is prime. There's nothing left to do here. X is prime, x squared plus 1 is prime. One way to check to make sure you're on the right track. This was a 5th degree polynomial. Notice, this was linear, this was linear, this was linear, this was a quadratic. Degree 1, degree 1, degree 1, degree 2. Add that up. 1 plus 1 plus 1 plus 2 is 5. Okay? If you were to multiply it out, you would get that x to the 5th. Okay, so let's do another one. Number 2. Why don't we do... So we're going to do x to the 5th minus 1 over 27 x to the 2nd. So first thing is we're going to check to see whether or not we have a greatest common factor. And we have a greatest common factor here, okay? We can factor out an x squared. That's going to leave us with x to the 3rd minus 1 over 27. And I'm going to turn the light back on, hopefully. Whoops, sorry. Hopefully we can all see that. Okay? So now we say to ourselves, okay, we factored out x squared. X to the 3rd minus 1 over 27. We need to check to see whether or not, okay, whether or not we can keep factoring this. So this is 2 terms. So we check for difference of squares, difference of cubes, sum of cubes. This is not the difference of squares. I can't take x to the 3rd and write it as something squared that will have an integer exponent inside. So the only thing I can check here is, can I write this as a difference of 2 cubes? Yes, that would be x, and this would be 1/3. So this fits the difference of 2 cubes factoring pattern. So you have to factor this expression. Okay, this is a, this is b. Remember, it's a minus b, so it's going to be x minus 1/3 times a squared, so that's x squared. And then difference of 2 cubes, the next term in this trinomial is always plus a times b. So plus 1/3 times x, so that's 1/3 x. And then it's always plus b squared. So plus, and then square this, you get 1/9. And what was the greatest common factor? Don't forget to put it back. X squared. So remember, now check. This is prime, okay? And this is prime. If you took out the greatest common factor, these are going to be prime, okay? I can't think of 2 numbers that multiply together to give me a 1/9 and add to a 1/3. And this is prime. Okay? So when you're factoring polynomials, you need to make sure you keep in mind all of your factoring patterns. Greatest common factor, quadratic trinomial AC method, difference of 2 squares, and now we've added difference of 2 cubes, sum of 2 cubes, factor by grouping, and quadratic form. Remember, you keep factoring. You factor until it's completely factored, which means you keep on factoring until all of your factors are prime. Okay, you keep checking. So now I just want to go over 2 problems that involve factoring. First, I want to go over what's called the factor theorem. And we're just going to write down our own version of what the factor theorem is. So essentially, okay, if we say if p of x is a factor of f of x. Okay? That means that p of x divides evenly into f of x. So if p of x is a factor of f of x, then f of x divided by p of x has no remainder. And what that means is, if I took f of x and I divided it by p of x, I would get a quotient, which we could call q of x. And so what that means is, if I took p of x and multiplied it by q of x, I should get back out f of x. Okay, but when you're a factor, it means you divide it evenly. If you divide it evenly, okay, that means that the remainder would be 0. And being a factor means you can write it as a product of its factors. Okay? So that's the factor theorem. And so we're going to use our knowledge of what it means to be a factor to do a few problems now. A remainder of 0 would mean that the remainder was, no remainder would mean that there was a remainder of 0, okay? So what we'll do right now is completely factor the following expression, which would be x to the 4th plus 3x to the 3rd minus 3x squared minus 15x minus 10 if x plus 2, or I shouldn't say if, given that x plus 2 is a factor. Okay? So we have to factor this big thing here. It has 5 terms to it. Now, I have no factoring pattern that's going to allow me to factor that, okay? I would be stuck because I can't factor this thing. But I'm given an advantage. I'm already told what one of the factors is. I already know that one of the factors is x plus 2. So, what that means is, my knowledge of factors is telling me, okay, that means I can take this expression and write it as x plus 2 times something, times its other factor. Now, how can I get the expression that if I multiply by x plus 2, I produce this thing? By dividing. I need to take this polynomial expression and divide out x plus 2. So I'll use synthetic division, -2, and then I check this is in standard form, and I don't need any placeholders. So 1, 3, -3, -15, -10. That gives me 1. 1 times -2 is -2. Add the column, 1. 1 times -2 is -2. Add the column, -5. -5 times -2 is 10. Add the column, -5. -5 times -2 is 10. Add the column, 0. You better get 0 here because you know that x plus 2 is already a factor. What we're trying to get is x plus 2 times what is giving us this expression. So if this is the remainder, this is the constant, this is x to the 1st, this is x to the 2nd, this is x to the 3rd. X to the 3rd plus x squared minus 5x minus 5. So this times x plus 2 is the same as this expression right here. But we have to check. So this might not be the completely factored form of this original expression here. We have to look. This expression right here that we just got as a second factor, perhaps it can be factored further. We have to check. It has 4 terms to it. X to the 3rd plus x squared minus 5x minus 5. 4 terms you should be factoring by grouping to try. So x to the 3rd plus x squared minus 5x minus 5. Group together the first 2, put a plus sign between, group together the last 2 terms. Take out the greatest common factor, x squared, that leaves you with x plus 1. Take out the greatest common factor, -5, leaves you with x plus 1. So this factors to be x plus 1 times x squared minus 5. So this is now x plus 2 times x plus 1 times x squared minus 5. Can x plus 1 be factored any further? No. Can x squared minus 5? Well, this could be the difference of squares or the difference of cubes. Okay, I can't take 5 and write as a perfect square, and I can't take 5 and write as a perfect cube using integer values. Therefore, this is the completely factored form of this. Be careful what your question is asking you. This one didn't say name all of the other factors knowing x plus 2 is a factor. Because if it did, you shouldn't name x plus 2 again. But this problem said completely factor this knowing that x plus 2 is one of its factors. Okay, just be very careful with what the question is asking you. All right, and one more problem. And the last problem is going to be find the value of k such that x plus 1 is a factor of f of x equals x to the third plus 4x to the second plus kx minus 20. Okay, so notice, here's the k. The coefficient on the linear term is missing. And what we're told is x plus 1 is supposed to be a factor of this. So what that means is x plus 1 should be divided evenly. That's the only thing we know right now is x plus 1 should divide it evenly. So what that means is the remainder better be 0. So what we can do is we can try and set up synthetic division and see where it gets us. So we know that when we divide by x plus 1, okay, into this function, we should always get a remainder of 0. So let's set up synthetic division. So this would be 1, 4, k, negative 20. Bring down the 1. 1 times negative 1 is negative 1. 4 plus negative 1 is 3. 3 times negative 1 would be negative 3. K plus negative 3, you can't add that together. Okay, they're not like terms. So this would just be k minus 3. Now, okay, think about this. We could do this two ways. If this is 0 and this is negative 20, you know what needs to go right here. 20 needs to go right there, okay? Or negative 1 times k minus 3. That's going to give you negative k plus 3, and then you add that. So negative 20 plus negative k plus 3 equals 0. So negative k plus 3 equals 20. So take away 3 from both sides, and you get negative k equals 17. So k equals negative 17. So what does k need to be? K needs to be negative 17 in order for x plus 1 to be a factor of x to the third plus 4x squared plus kx minus 20.